So here we've got problem number 45 from chapter number 2 in our textbook. And it reads, a rock climber stands on top of a 50-meter high cliff overhanging a pool of water. He throws two stones vertically downward 1 second apart, observes that they cause a single splash. The initial speed of the first stone is 2 meters per second. So A, how long after the release of the first stone does the second stone hit the water? B, what was the initial speed of the second stone? And C, what is the speed of each stone as they hit the water? So part A, right, they're asking for what is the time for the first rock to hit the water, because they're both going to hit the water at the same time. So the time between the release of the first rock and the second rock hitting the water is equal to the time of the first rock. They then would like to know at what speed does the second rock need to travel so it hits the water at the same time as rock 1, and then what is V sub f for both of them. Okay, so part A, just finding that time. All right, so if we know the height, we can usually find the time. We're going to go with that second kinematic equation of y equals y sub o plus v sub o, call that 1t, plus 1/2 g t squared. Plugging in our stuff, if this is 0, then this is negative 50 if we're taking where the man is standing to be our origin. So we'll have negative 50 is equal to 0 plus 2 times t, negative 2 times t, plus 1/2 negative 10 t squared. So if we do a little rearranging, we get 0 is equal to negative 5 t squared minus 2t plus 50, which is a nice quadratic equation, right? And if we're going to find the roots, there's a couple ways to do that. We can do the quadratic formula, solve it all out, we'll get 2 answers. Your calculators can do the work. You can also find quadratic solvers on the internet. So if we plug those numbers in, we find that the time is going to be 3 seconds for the first rock and the second rock to hit the water. The first rock travels for 3 seconds. The second rock will hit the water at the same time, the same moment, I should say, but it may not necessarily be the same time that it happens. Okay. So now we want to find out for part B, at what speed does rock number 2 need to travel so that it hits the water at the same moment as rock 1? So if rock 1 does it in 3 seconds and rock 2 gets dropped 1 second later, that means that rock 2 needs to travel for 2 seconds if it's going to hit the water at the same instance. Okay, so that we know that we can solve for that all over again, using the same kinematic equation as the first time. So again, it's going to travel 50 meters downwards. 0 plus, now we've got v sub o 2 times 2 plus 1/2 negative 10 and then 2 squared. So solving for v sub o 2, we find that it needs to be thrown at 15 meters per second if it's going to hit the water at the same moment as rock number 1. So then for part C, how fast are they when they hit the water? All right, rock 1, let's use our first kinematic equation, v sub f equals v sub o plus gt. So that's going to be, it was thrown at negative 2, and then gravity pulls on at negative 10, causes accelerate negative 10, and rock 1 was in the water for, in the air for 3 seconds. So we find that the final speed of rock 1 is going to be negative 32 meters per second, or another way of saying it is 32 meters per second and downward when it hits. All right, and then for rock number 2, same exact process. Only this time, rock 2 need to be thrown at 15 meters per second downward, and it's going to have, again, an acceleration of negative 10, which gravity pulls all objects at, causes it all to accelerate at -10, but this one travels for 2 seconds. So we find that the second rock has a final speed of -35 meters per second when it hits the water. And they both hit the water at the same exact time. Okay? So that was problem number 45 from chapter 2.